Good morning. Today we will deal with concept of isomerism. Now, what are isomers? Those organic compounds which have same molecular formula but different structural formula, or we can say difference in their physical or chemical or both properties, are known as isomer, and this phenomena is known as isomerism. Basically, isomerism is of two types. One is structural isomerism and another is stereoisomerism. Now, what is structural isomerism? Those organic compounds which have same molecular formula but different structural formula are known as structural isomer, and this phenomenon is known as structural isomerism. They are of six types: chain isomers, position isomers, functional group isomers, metamers, tautomers, and ring chain isomers. Now, what is stereoisomers? Those organic compounds which have same molecular formula but arrangement of atoms in space is different are known as stereoisomers, and this phenomena is known as stereoisomerism. They are of two types: conformational isomers and configurational isomers. Now, what are chain isomers? Those organic compounds which have same molecular formula but difference in arrangement of carbon chain are known as chain isomers, and this phenomena is known as chain isomerism. For example, normal butane and isobutane both have same molecular formula C4H10, but normal butane contain chain of 4 carbon atom and isobutane contain a chain of 3 carbon atom. Normal pentane, isopentane and neopentane, all these three compounds have same molecular formula C5H12, but normal pentane contains a chain of 5 carbon atom, isopentane contains a chain of 4 carbon atoms, and neopentane contains a chain of 3 carbon atom. Although they have same molecular formula, but there is a difference in the arrangement of carbon chain. So they are chain isomers of each other. Now, what are position isomers? Those organic compounds which have same molecular formula but difference in the position of double bond, triple bond, substituents, or functional group are known as position isomers, and this phenomenon is known as position isomerism. For example, C4H8, 1 butene and 2 butene. Here, in case of 1 butene, the double bond is present on first carbon atom, and in case of 2 butene, the double bond is present on second carbon atom. So the position of double bond differs, although they have same molecular formula C4H8. Another example is 2 butene and 1 butene. Both have same molecular formula C4H6, but there is a difference in the position of triple bond. Here the triple bond is present on second carbon atom, and here the triple bond is present on first carbon atom. Another example is 1 chloropropane and 2 chloropropane. Both these compounds have same molecular formula C3H7Cl, although there is a difference in the position of halogen atom. Here the halogen is present on first carbon atom, here the halogen is present on second carbon atom. Now, another example is 1 propanol and 2 propanol. These both compounds have same molecular formula C3H7OH. Here the OH is present on first carbon atom, and here the OH is present on second carbon atom. So they are position isomers of each other. Another example of orthoxylene, metaxylene and paraxylene. Here the position of methyl group differs. Next, functional group isomerism. Those organic compounds which have same molecular formula but difference in their functional group are known as functional group isomers, and this phenomenon is known as functional group isomerism. For example, alcohol and ether, ethanol and methoxymethane. Both these compounds have same molecular formula C2H6O, although alcohol contains OH functional group and ether contain ether functional group. Acid and esters are also functional group isomers of each other. Aldehyde, ketones and enols. See here, this is propanol, propanol and prop-2-in-1-ol. All these three compounds have the formula C3H6O, although they differ in the functional group. Here aldehydic functional group, here ketonic, here they are having enol functional group. Next example is ring chain isomers. Here 1-butene and cyclobutane. Both have same molecular formula C4H8, although 1-butene has a chain of 4 carbon atom and here cyclobutene is a ring structure. So they have same molecular formula but they differ in their arrangement of chain or ring. Hence they are known as ring chain isomerism. Next example of isomerism is metamerism. Those organic compounds which have same molecular formula but differ in the arrangement of alkyl group to a polyvalent atom are known as metamers, and this phenomenon is known as metamerism. If we consider the example of ethoxyethane, 1-methoxypropane and 2-methoxypropane, all these three compounds have same molecular formula C4H10O, and oxygen is bivalent and there are two different alkyl group, ethyl groups are there. Here methyl and propyl group is there and here methyl and isopropyl group is there. So having same molecular formula but the arrangement of alkyl group to a polyvalent atom differs are metamers of each other. Here the carbon is tetravalent and the carbon has ethyl groups, methyl, propyl group, methyl and isopropyl group. Hence this is diethyl ketone, methyl propyl ketone, methyl isopropyl ketone. All these three compounds have same molecular formula C5H10O, but the arrangement of alkyl group to polyvalent atoms differs. Hence they are metamers of each other. Next type of isomerism is tautomerism. It is a special type of functional group isomerism having same molecular formula but the migration of proton from one polyvalent atom to another by the mutual migration of double bond are known as tautomers, and this phenomena is known as tautomerism. If we consider the example of acetaldehyde, ethanol, here the migration of proton from one polyvalent atom, say carbon, the migration of proton from one polyvalent atom to oxygen. So migration of proton from one polyvalent atom to another by the mutual migration of double bond. This is known as keto form, and here this is known as enol form. Hence both these forms are interconvertible and hence it is also known as keto enol tautomerism. It is a special type of functional group isomers. Here the functional group is also changes. See here aldehyde group, and here the compound is having enols. Now, what are stereoisomers? Those organic compounds which have same molecular formula but the arrangement of atom in space is different are known as stereoisomers, and this phenomenon is known as stereoisomerism. And stereoisomerism are of two types: configurational isomerism and conformational isomerism. Now, what are conformers? Yeah, conformational isomerism. Those organic compounds having same molecular formula but arrangement of atoms in a molecule due to free rotation around a single bond is known as conformers, and this phenomena is known as conformational isomerism. Here is an example of conformers of ethane. This is eclipsed form of ethane, and this is staggered form of ethane. Now, what is configuration isomerism? Those organic compounds which have same molecular formula but arrangement of atom in space in molecule differs, and the conversion of one configuration into another is possible by breaking up a bond and making up of a new bond. If we consider the example of D-glyceraldehyde and L-glyceraldehyde, here the OH group is present on right hand side nest, that is D form of configuration is there. Here the OH group is present on left hand side, hence this is L form. So these are known as configurational isomerism. So this is all about the concept of isomerism. Thank you.